What actually happens the moment you hit enter. Not the marketing description, the real control flow. One function decides everything. When to call a tool, when to retry, when to give up, and when to finally answer you. Today we open it up. Welcome back to the Hermes Agent Deep Dive. In part 1, we map the repository at a high level. This time we go one level down, into the actual loop that turns a single user message into a finished answer, calling tools along the way. Everything here comes straight from the pinned V 2026. 7. One release of NousResearch's Hermes Agent, with every file and line number cited on screen, so you can open the same code yourself and follow along. By the end of this part, you'll understand 5 things. Why the AI agent constructor barely does anything itself, and instead forwards everything to a separate init function. The while loop inside run conversation that drives every single tool calling turn. How an iteration budget, plus something called a grace call, brings a runaway turn to a clean stop instead of an ugly crash. Where exactly tool calls get executed once the model asks for one. And finally, how the loop recognizes a normal finished answer and breaks out cleanly. This is the part of an agent framework most tutorials skip, and it's the part that actually matters when your agent misbehaves. Strip away the error handling, and one turn is 5 stages. Setup handled by a helper called build turn context, which restores or builds the system prompt and prepares the message list. An API call to the model, after sanitizing any corrupted tool arguments left over from a previous turn. A branch, did the model ask for tools or did it give a final answer? If it asked for tools, they get executed, and the results go back into the message list. And then the loop either starts over with those results, or breaks out with a finished response. Stages 3 and 5 are the whole reason this is a loop. Instead of one API call, a single user message can trigger dozens of these round trips before you see an answer. Before we dig in, a few things help. Python 3, 10 or newer, and your own clone of the Hermes Agent repository. Check out tag V 2026. 7. One specifically, that's the exact snapshot this whole series cites, and line numbers will drift on newer commits. You don't need to be an expert in agent frameworks, but some comfort reading a large, real production codebase will help, because this is not a toy example, it's the exact file that ships. Have run agent, Pi and agent/conversation loop. Pi open side by side, because we jump between them constantly in this part. Here's the first surprise. AIAgent's constructor, at line 426 of run agent. Pi takes more than 60 keyword arguments callbacks for streaming, tool progress, thinking, notices, credential pools, checkpoints, everything. But look at the body. It does nothing except call inner agent from a separate module and hand every argument straight through. The docstring even says so, quote forwarder end quote. Why bother? Because inner agent, an agent/agent in it. Pi can be tested and reasoned about on its own, completely decoupled from the class it initializes. It's a small pattern, but it's the first sign that this codebase takes separation of concerns seriously, even inside its own constructor. This is the function everything in part 2 is really about. Run conversation, starting at line 518 of conversation loop. Pi. It takes the agent instance itself as its first argument rather than being a method on the class, plus the user's message, optional conversation history, a task ID used to isolate sandbox tool environments between concurrent tasks, and a stream callback, the text-to-speech gateway pipeline, uses to start speaking before the full response is even done generating. One call to this function runs an entire turn every API call, every tool execution, start to finish, and returns a dictionary with the final response and the full message history. Before any looping happens, run conversation calls build turn context once. This one call handles everything that only needs to happen at the start of a turn, guarding standard input and output, resetting retry counters, sanitizing the incoming message, restoring or rebuilding the system prompt, persisting state for crash resilience, running a preflight compression pass if the context is getting large, firing a plugin hook called pre-LLM call, and prefetching from external memory, pulling all of that into one helper function, defined separately in agent/turn context. Pi keeps run conversation itself focused on just the loop which, as you're about to see, is already plenty complicated on its own. Here's the actual loop. It keeps going as long as two conditions both hold. You're under the max iterations cap, which defaults to 90, and the agent's iteration budget still has some remaining. That second part, matter's iteration budget, is a separate tracked resource from max iterations, and it can be shared across a chain of subagent calls, not just one turn. There's also an escape hatch called budget grace call. If the budget just ran out, the loop is allowed exactly one more pass rather than cutting the model off mid-thought. And right at the top of every single iteration, the loop checks for an interrupt request, which is how a new message from the user can break a long tool calling chain immediately, mid-turn. Every iteration spends 1 unit of budget by calling iteration budget.consume. If that call reports nothing left, and this isn't the one free grace call, the loop records why it's exiting, the string budget exhausted, prints a warning and breaks. Notice that exit reason. It's not a Boolean, it's a short diagnostic string, and the loop sets one of these at every single exit point. That turns out to be the single most useful debugging feature in this whole function, because when someone reports a turn that stopped early, you don't have to guess which of a dozen conditions triggered it. You just read the exit reason back out of the logs. After the API call returns, this is the fork in the road, around line 4263. If the assistance message came back with tool calls attached, they get validated, then handed off to agent_execute tool calls at line 4531, a separate method that actually runs each tool, whether that's a file edit, a terminal command, a web fetch, or a call into another subagent, and appends the results as tool role messages. If a safety guardrail trips during that execution, the loop exits immediately with the reason guardrail halt, before ever going back to the model. Otherwise, the loop simply continues, and those fresh tool results become part of the next API call's context. And here's the other branch. If the assistance message has no tool calls at all, that's your answer. Final response gets set to its content. The exit reason becomes text response with the provider's own finish reason attached for debugging, and the loop breaks. That's the entire termination condition for a normal, successful turn. No special flag, no separate completion check, just the simple fact that the model chose not to call another tool this time. Everything before this point, however many tool calls it took, was in service of reaching this one moment. And when the loop finally ends, run conversation doesn't even build its own return value. The last 5,000 lines have been building up local variables, final response, how many API calls it took, whether it was interrupted, whether it failed, the full exit reason, and at line 5137 all of that gets handed to a separate function, finalize turn, imported from agent/turn finalizer.py. The comment above it says exactly what's going on. This is a, quote, God file decomposition, end quote. The original giant function is being broken apart into focus pieces, on purpose, one extraction at a time, without changing behavior. Even the file explaining its own control flow to you is a live example of the practice. A few notes before you go spelunking in your own copy of the repo. Pin the exact tag or commit you're reading against. This fast-moving codebase reflows line numbers constantly, and citing the wrong one is worse than not citing one at all. Iteration budgets and that guardrail halt exit reason aren't friction to route around. They're the mechanism that stops a misbehaving tool loop from running away and burning API calls, or taking destructive actions unsupervised. If you're extending this pattern in your own agent, keep all tool safety checks funneled through one execution point, the way execute tool calls does here, instead of scattering them across every tool. And when you change defaults like max iterations, verify against the real value in the source, 90, not whatever number you remember from a blog post. One practical habit if you're following this series long-term. Hermes Agent doesn't stand still, so schedule a simple weekly check comparing the pinned tag against upstream main. One cron line, running every Monday morning, fetches tags and lists every commit that's landed since V2026. 7.1. It won't rewrite this tutorial for you, but it tells you exactly how stale the line numbers on your screen are getting, and whether a part covering, say, the tool registry or the memory system is worth rechecking before you build on top of it. Let's pull it together. The AIAgent constructor is a thin forwarder. All the real setup lives in an agent, kept separate on purpose. The actual work happens in run conversations while loop, gated by max iterations and a shared iteration budget, with one grace call so a turn doesn't die mid-thought. Every iteration ends at a fork. Tool calls get handed to execute tool calls and the loop continues, or their absence means you have a final answer and the loop breaks. And even the return value isn't assembled inline. It's handed off to finalize turn, the same decomposition pattern you saw in the constructor. One file, one loop, and a lot of very deliberate separation of concerns. That's the agent loop, the engine room of Hermes Agent, straight from the pinned source with every line cited. Part 3 goes one layer deeper, into how the system prompt itself actually gets assembled turn by turn, in system prompt. Pi and prompt builder. Pi, the stable, context, and volatile tiers that decide exactly what the model sees before it ever calls a tool. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 3.